Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. I begin this presentation with basmala and enjoy with my presentation. Thank you for joining me today. My name is Inas Audi Hafid, and I'm here to present my project, optimization of the column stripper in PTH. Before we get to the deep discussion, we must know what is the main parts of a stripper column in CDU, crude distillation unit. Component inspiration. The first component inspiration is responsible for separating the components of crude oil based on their different boiling points. The stripping process involves the use of steam to vaporize the lighter components, allowing for efficient separation between different fractions. And number two is removal of impurities. The stripper column also plays a role in removing impurities or compounds that are bound within the oil. By using steam, these impurities can be vaporized and separated from the main products. Number three is product quality enhancement. The stripper column helps improve the quality of the products by separating the desired component from the undesired ones. With proper separation, the resulting fraction have higher quality and meet stable standards. Uh, Next, thermal stabilization. The stripper column can also be utilized for thermal stabilization process. This involves removing easily vaporizable compounds from heavier fraction. And number five, aspiration of operational efficiency improvement. By employing an effective stripper column, the CDU unit can achieve high operational efficiency, good separation between different fractions in pure products that meet desired specification. Optimization is the process or activity of improving or maximizing like efficiency, performance, outcome, or profiles. One approach to optimization involves researching the operational parameters associated with the stripper column by analyzing the current operation condition such as temperature, pressure, flow rate can be made to enhance sparing efficiency. Setting these operational parameters can also help determine the best condition to achieve maximum product yield. Additionally, an analysis of optimal steam use is necessary. Inefficient steam utilization can result in energy waste and high costs. During the optimization process, a thorough study is conducted to determine the required amount of steam for achieving the most efficient operation condition. By optimizing the stripper column through adjustment in operational parameters and optimal steam use, it is expected the quantity of product generated can be increased. Furthermore, energy use can be optimized, reducing waste and operational costs. Okay, let's go to the first content. There is a table of fuel sales data from Indonesia Ministry. Fuel oil consumption continues to increase from year to year in 2021 when the coronavirus occurred. Fuel consumption reached 70 million. Moreover, if there is no activity restriction, it may be more. To meet the increasing demand from fuel supply, the government needs to ramp up domestic fuel production. This can be achieved by optimizing production in existing oil refineries. These are challenges faced by the researcher for how to improve the performance of the LGO stripper column. We will use the trial method on the steam flow rates and will analyze its correlation with the product output. And of course, we will also compare the economic after obtaining the optimization result. The second topic is data observation. This is data of the data material of feed composition and operation data in January 2021, 2023 in stripper column. and that is the design data, its operating limits. And we use the software of HiSys and Excel and also the Microsoft Word. That is average of the operating condition of my company. That is average of operating condition uh 1 month. And that is the laboratory analysis. We enter the third topic, the discussion. Okay, that is the PFD of the CDU unit. Crude oil feed is pumped with a booster pump to the desalter. Before entering the desalter, the crude is heated in a series of heat exchanger, which utilize heat from the column. After passing through the heat exchanger, the flow is injected with water and emulsifier. The addition of water is meant to dissolve the salts in the oil, while the emulsifier serves to break the emulsion between water and oil. The dissolver serves to separate the dissolved salts in the crude oil with the help of high electric field. The spirited water is sent to the corrected pit at the receptor or CPI, while the impurities-free crude oil that comes out of the desalter is entered into the heat exchanger and fire heater to be heated. After heating, crude oil enters the main fractionation column at the temperature of 300 to 330 for 30 degree. Because some of the HGO fraction is still included at the bottom of the main fractionation column, low steam is injected with a pressure of 3 kilogram per centimeter cubic. This is to reduce the partial pressure of the hydrocarbon so that the light fraction still present at the bottom can be vaporized. Overhead gas coming out of the top column is injected with an H3 and corrosion inhibitor. Okay, let's go to the characteristic of fluid on the tray is two type. Whipping. Whipping is when the vapor pressure is too low and the liquid drops into the tray below. The impact is the disruption of the dispersion that could occur between the heavier components at the bottom of the column and the lighter components at at the top of the column. This can lead to contamination of the top product by the bottom product. And number two is flooding. The flooding is when the vapor pressure is so high that liquid builds up on the downcomer and some component can rise to the tray above. The result is a waste of energy due to overpressurization. When the tray is flooded with liquid, the contact between liquid and vapor is inhibited, reducing the aspiration efficiency of the component in the column. This is a view of the weeping on the tray. Okay, let's go to my analysis is find out the weeping and flooding condition. We can use the hydraulic plot on the high seas. This is the research of actual condition. The condition on all trees don't occur weeping and flooding, but there are warning signs that indicate some attention and monitoring of the column operation condition. However, this doesn't indicate a serious problem with the column operation. Instead, the warning signs can serve a reminder to monitor and inspect the operating condition more closely to ensure optimal performance. This step for finding the optimum operating conditions in the stripper column. First, we trial the independent variable. The variable independent is stream of flow rate. Then we will analyze the trial data that has been collected. From the trial data, we can find the optimum point in the operating condition in the strip column. This is the result of hydraulic on the high seas. There is an indication of weeping on a stray egg. So this case does not fulfill its optimum point because the color is red. The same as case 7, there is an indication of weeping on the tray 6. So this case does not fulfill its optimum point. Okay, case 5, 4, 3, and 2 in 1. This is same case. This indicated the optimization condition. That's case 7. Case 7 which is marked in blue color. It shows no indication of flooding and weaving, so the operating condition can be applied to the strip or column. By comparing also the design limits and specification limits, we choose the condition in case 7 as the optimal points. This is graphic comparison between the use of steam and the number of the LGO product produced. From the graphics can be seen the more steam use is in the strip column, the less bottom product is produced. This is in line with the theory of existing distillation principles, and the optimum point of operating condition is at the use of the amount of steam uh, or 0.447 ton per hour. The following is the table of economic calculation. It is known that there is an increase in profit when compared to external conditions. The next topic is the conclusion of the research that has been done. First, we can conclude that it increased the performance of the stripper column. We can do so by the term determining the optimal steam use, so that the performance of the stripper column can be increased. Second, the use of steam has effect on LGO products. From the research conducted, you, if you reduce the use of steam, LGO products will increase. And number three, the company profits by applying optimal condition can increase the benefits of up to 24. Okay, this presentation for me, Audi Hafid. Thank you for giving me for coming late. Thank you.